Well, I think first that I love talking to you. I mean, it's been really nice to sort of explore this.
Thank you.
It's not a lot of times we just have our kind of nose in the
Right.
laptop and the books, and we're trying to like write what we need to write and do the deliverables in our research, right? But it's nice to have the wider ranging conversations, and I think that for me these sorts of conversations are so important in general because we need to think with the wider angled lens in order to really be responsible about how we use AI and machine learning systems.
Science. Technology. Medicine. Health. These four things make the world go round. Without them, we couldn't exist. This is the Monday Science Podcast, a weekly show bringing you the latest research and news in science, technology, medicine, and health, answering your questions or finding experts in the field to answer them. Your host is a pharmacist, an award-winning scientist. She leads her own research group and is the founder of King's College London Fight the Fakes. A tad bit on the qualified side. Welcome to Monday Science. Here's your host, Dr. Bahijja Raimi-Abraham.
On today's episode, we have Dr. David Leslie. Hello, David. How are you?
Hi, I'm doing great. Nice to be here.
Please tell us a little bit about yourself.
Well, I mean, I guess I've always described myself as a kind of itinerant intellectual in terms of just being very interested in the world. But I guess over the last 7 or 8 years, I've really focused a little bit more on thinking about the ethics of technology. I was kind of raised up as a philosopher, thinking about how things in the biggest sense of the word fit together in the biggest sense of the word, that kind of trying to make sense of our existence. And so, but now I've focused a little bit more, and I'm currently the ethics theme lead at the Alan Turing Institute, where we do a lot of work in supporting the public sector to sort of design and develop responsible technologies in applied data science and artificial intelligence. And then we also do, I think, just as much work in what we might think of as AI and society. So this is this idea that data intensive technologies and artificial intelligence, however we want to define that, is not just a technical phenomenon in the world, but rather it's also a socio-technical phenomenon. In other words, there are deep cultural, historical, political, economic conditions of possibility for technology, and we really need to look at all of our technologies, including AI and data-intensive technologies, in those circumstances. That we need to understand what are the material conditions of production, how are they impacting the individuals and communities they affect, that sort of thing. And so now I guess I would sort of identify more with thinking in that space. So I think it's really important, even when you concentrate on things like that, to remain have a wide-angled lens, if you will, and then also think about the bigger picture of not just our contemporary society, but our situation as a species and our situation in terms of our place in the greater biosphere, in the greater kind of scheme of living beings on Earth.
I've been on my own journey of understanding with AI and tech. And when you talk about the ethics of technology, this is such a timely conversation, in particular where tech has been even more so in the forefront and more front of discussions and everything. But before we get into it, I'd like to make sure we're all on the same page. So if you could explain to us, what is AI? So what is artificial intelligence?
Wow. So I'll just say that I shouldn't divulge this, but when we're doing interviews for candidates who are going to come and work with us at the Institute in the public policy program, that is one of our interview questions. So you're feeding it back to me. So I mean, one way I think the best starting point in thinking about what AI or artificial intelligence is to think about effectively computable systems, so algorithmic systems, computational systems that operate in the world and serve surrogate cognitive functions. So they stand in for informed or intelligent activities that, if done in the world, are likely to have been done by an intelligent being, a human being. And so I think from that sort of starting point, we can really think of AI in a functional way, which is to say, when we think about what artificial intelligence is in the world, it's those mechanistic systems that are standing in for us in predicting something, classifying something, identifying clusters of things. And at the end of the day, these are probabilistic and statistical programs for the most part, and some incorporate logic as well, logical systems as well. But at the end of the day, they're mechanistic. They're, as we would say, syntactic. Now, syntactic meaning they are processing binary based upon sets of procedures and rules, rather than, in a sense, understanding and coping with the openness of meaning in the world, which is what we do when we kind of navigate all of the uncertainty and work through language and communicate with each other. Now, that starting point, I think, is, as a definition, an important one, but I think it's also important to step back and really think about AI in terms of the complexity of the supply chain of what AI is. So AI is really highly dependent upon a whole set of human practices that go straight from the very early moments of how we build the hardware, how we're able to build the hardware, the silicon-based hardware behind computational systems. That we have to think about that when we think about AI, because there are certain accessibility and entry costs that come along with having access to certain degrees of effectiveness and quality in those real parts. But we also have to think of the other various components of the supply chain. So the data that's collected, right? The medium of delivering the systems. So think about the fiber optics, the internet, all of the various cloud computing forms, data lakes, and all of the other components of infrastructure that are necessary for AI to exist. And then there's even at the higher level a whole set of procedures and expertise and levels of education and corporate and government capacities that factor to the way that the AI systems, the algorithmic systems, are constructed and produced, right? So it takes a high degree of expertise to build out these types of mechanical systems, and all of this is part of the AI supply chain. And so I think if we're going to really confront the bigger picture issues in society and ethics that are related to so-called AI, artificial intelligence, we really do need to be aware of that kind of wider schema of materials and processes.
Yeah, because I guess when I think of AI and artificial intelligence, I think in a very, I guess, in the cloud sense, which is obviously not accurate. And when you were mentioning the fiber optics, things, I was like, oh yes, of course, because you need to have a computer or whatever platform that has enough capabilities to handle the AI. I just wanted to, before we move on to the next question, logic. That I remember a friend of mine studied philosophy. I had a friend of mine that studied philosophy at university, and logic is a form of philosophy. Is that right?
It is. Yes, it is.
Yeah.
Some would say, I mean, it depends on what type of sort of school of thinking that you subscribe to in philosophy. But some philosophers would say that logic is the most kind of basic philosophy, because if you think about language itself, like we think about, we're what Heidegger called Zoon, Logon, Echon, we're animals that kind of navigate the world in language. And if we think of ourselves as linguistic beings, some philosophers would say, well, what is the very kind of basis of language? How do we understand language? And Chomsky, for instance, builds out a very interesting system of thinking about language that is absolutely anchored in the fundamentals of logic, the kind of this capacity for recursive enumerability in combining symbols in particular, based upon particular rules and in accordance with particular rules. And so logic, I think, is a very important part of how we think of artificial intelligence. Also, really quickly, just historically, artificial intelligence first emerged, or the kind of field of artificial intelligence first emerged in the mid-1950s. And around that time, so originally 1956, there were various camps that wanted to kind of think and talk about what complex information processing actually is or was. And that was the starting point of thinking about what AI. I mean, we thought about how does information processing happen? And so from the 1950s for the next decades, I would say, what we call GOFI, good old-fashioned artificial intelligence, was logic-based. It was symbol-based. And so, for instance, we thought that we could address a lot of the problems in the world, right, by starting with rules and then, in a sense, anticipating the activities in the world based upon logical rules and how those logical rules fit together. I'll also say that at the very beginning, even earlier, at the very beginning of the creation of computational systems, I have to mention this because I'm from the Alan Turing Institute, but Alan Turing himself basically was navigating the world of metamathematics and logic. And the way that we came to define what would come to be known as a Turing machine and then a universal Turing machine was through a kind of degree of logic. Turing, in a sense, detranscendentalized logic and made it more practical. But at that point, computational systems and computational infrastructures came to be based on what we call Boolean logic. So very simple and, or, and NAND signs. And that's all logic at the end of the day. So when our computers right now are operating what's going on in the electrical pulses are all logical operations, what we would call. So logic is omnipresent in where we are right now.
Thank you so much for that, because it's so fascinating when you see how different disciplines, different fields all come together for that one thing. Because I don't think people would understand that we think artificial intelligence, we think tech, and in the first few minutes, you've blown my mind because you've highlighted the impact of philosophy in that, in the build up, in the considerations. So in a way, it's sort of unifying us all a little bit more. Okay, so what are the 4 principles of explainable AI? What does that mean? What is explainable AI?
Yeah. In a sense, we're at a point now, just to step back for a second, where our capacities to process information, just in terms of the actual underlying hardware, have increased over the last couple decades in ways that have enabled us to use what we call very high-dimensional models, right? So, for instance, we can use artificial neural nets that might have as many as millions or even billions, if you think about more recent systems, parameters that are kind of operating when the system is inputting data, and those billion or millions of parameters are basically acting as a mapping function that allows a system to come up with a classification or prediction or whatever the purpose of the model is. And one of the challenges for us as human beings is that we can build these things, right? But our semantics, so our capacity to understand the moving parts of the world are in a sense limited. So you and I, when we think about the interactions of variables in the world, we're maybe able to, at any given time, to think of a few variables at a single point, to think about, well, A causes B or A is related to B. And so we can think of a few factors and understand their relationships. And that for us gives access to an interpretation of a context or a situation. What changes with these high-dimensional, very complex models is that it's not just that there are a few factors that are determinative of an output or prediction, but there are like literally hundreds, thousands, millions, billions of factors that are intertwined in various ways. And that comes to be beyond what we would call human scale reasoning, in the sense that we just can't hold all of those things together in our mind, right? So for instance, a support vector machine might have what it's doing is it might be separating variables. So say there were only sort of two parameters. It would be sort of separating variables with a line, is to separate them in one dimension. But now keep adding dimensions to it, and suddenly we're okay thinking 3 dimensions, maybe 4 dimensions, but then one of these models might be thinking in 85 dimensions, and we just simply can't. The way our experience in the world works and the way that our understanding works, we don't have the capacity, in a sense, to sort of work in that space. And so explainable or interpretable AI is dealing with this dilemma, in the sense that when we think about, well, how do we come to understand the rationale behind a system like a neural net or some of these other complex systems, a random forest, which is another sort of complex model. How do we sort of gain a grasp or a foothold in understanding why or how a set of inputs are transformed into an output or a set of outputs. And so explainable AI or interpretable AI, I think they're slightly different. We can talk about that in a second, but it has to do with ensuring that any given system is appropriately understandable in plain language to those who are impacted by the system. And that really means a lot in the sense that, so if I have a very impactful system, say it's a predictive risk model, right, that is predicting let's just think of a case in children's social care, because we published a report on this earlier this year. So if I have a predictive risk model in children's social care, that's supposed to be decision support for a social care worker who is trying to sort of predict the risk of a child given a set of conditions, a set of inputs that are put into a certain algorithmic model. I'm definitely going to want to have a system that is accessible both to the social care worker and to the impacted family, because we want to understand, well, what are the cumulative factors and correlations that are factoring into the production of a high risk score and output. And the only way that we're able to do that and understand those determinative factors in the context of the particular person's situation is by having as we would say, a transparent system. And so interpretability is being able to understand the system, and explainability is being able to understand that, being able to explain that interpretation to people. And this is important for a lot of reasons. First, because a system that isn't transparent won't give us access to potential factors that are biased or discriminatory when we sort of lift up the hood and try to understand, well, what are the possible confounding factors here, or what are the potential historical biases that have made inroads into the system. If you don't have a transparent system, you won't be able to understand the kind of bigger picture of the potential harms that might be done by that system in terms of the social costs. And then at the same time, if it's a highly impactful system, say in medical or clinical diagnostics, if you don't have an interpretable system, first, it won't provide a decision support for evidence-based reasoning. But second, it won't, in a sense, support assuredly safe outcomes. Because if you can't interpret a system, one then won't be sure if it's brittle in a certain situation that becomes unfamiliar, or in novel situations that haven't been accounted for in the mapping function. So explainability and interpretability is crucial for us to be able to use these systems in impactful environments. And so, yeah.
That the link with healthcare is actually what started my own personal journey in trying to understand ethics. Being a pharmacist, my research is in drug development and all that stuff. So it's like, how does this, because we're seeing more research that's and I mean this in all, I don't mean it to sound as judgmental, but sometimes, as you would know with research, things can be a buzzword, right? Yeah. It's like you could say, oh, everything is now including AI, and oh, we're doing deep learning. But I don't feel that people fully understand sometimes in other sectors where we're just coming in and we're trying to understand, and we're seeing through the grapevine that these tools that we're learning of can help us somehow in our research. But then I think there's that gap in, I was going to say, gap in understanding, but maybe gap in appreciation for these sorts of considerations. Because I was just taking notes here, by the way. It's like I'm enjoying myself. But I was just that when you were talking about when you explained the explainable AI, and then you needed to also be transparent and being able to make evidence-based decisions, that obviously that's important, because that's what we're trying on a human level. That's what we're trying to do. So if you don't give the AI the platform with the ability to be able to do that, then you're going to get negative outcomes. And actually, because I did read the draft, I'm actually looking at my notes, at NIST IR 831 document, but I noticed there was a section that said humans as a comparison group for explainable AI. Could you, what is that? What does that mean? And could you just explain what that means, and how humans are used as a comparison for AI or any other tech? Is that something that happens?
Yeah, I mean, I think, well, so let me also just quickly say, because you mentioned the role of AI in drugs and the development of drugs, and this has really been an important part of the COVID-19 response to that we have been able to marshal certain algorithmic systems, highly complex ones, to support in drug discovery. And I think there is something to be said also here for the more complex systems in scientific discovery. So we will be able to use what we would consider opaque systems as a helpful tool in scientific discovery, because these systems can pick up patterns, right, that are inaccessible to us, that then can be used by researchers in an evidence-based way, of course, but they could be uncovered by certain algorithmic systems and then come to help and support innovation on our side of things, right? And so there is a role, I think, for the more complex systems, but we really need to keep them in the appropriate place and understand that when you're using a system like that, it's important to try to understand it in the first place, but there are real advantages to being able to process very, very complex data through these systems in terms of our ability to gain insight about the environment, insight about the universe in general. And so I would flag that it's important to also make distinctions, say, between the way we would use a decision support system, which has a very different function than, say, a drug discovery system that's working on. You've got these systems that are basically they're being inputted with studies, right? Thousands and thousands of studies, and finding proximities between effective drugs, right? And so that would take human beings hundreds of years to do the same work, right? But it's basically assisting us to cut through and find some patterns that we might not have seen otherwise. But yeah, I mean, I would say in terms of the comparison between humans and AI, I mean, I think we should take it should give us pause when we take the technological tool and give it some sort of independent status. I don't believe that that's the right approach in general. I think we should always treat these as tools of our own design, of as the philosophers would say, that arise from our will and artifice, right? That we make these things, right? We're the creators of these things, and for that reason, I think they're always embedded in our practices in ways that we shouldn't compare, because I think it's a bad starting point, if you will, because it's like you're creating you're creating this whole kind of mythical independence of something which is actually a socio-technical product, right? Yeah. And I think that's been some of the traveling down, I think, unhelpful paths in contemporary AI has been caused by this kind of conception that AI has this independent kind of status from beyond, that goes beyond our using it to try to help our situation.
And I think that's where also the potential for fear of AI comes in, because it from what I'm understanding in particular from this conversation, it's whatever you create, if you don't apply whatever you create has the potential to expand and do its own thing. And as you mentioned, that's sort of the dimensions of thinking and how humans' limitation in the number of dimensions they can think versus the computer. That means that you've got that sort of a just completely different system going beyond our own potential of understanding. And so therefore, if you allow that to run wild, as it were, and then rely on that in a way that you're giving it ownership, not just of itself, but potentially ownership of you, then you can, and I'm guessing, is that sort of one of those big, because you mentioned, I noticed you called it like contemporary AI. So is that one of the challenges now with contemporary AI, this potential of letting well, and I don't know if I'm sort of explaining this right, but allowing the system to be I don't know if you've seen the film Transcendence with Johnny Depp. I don't know if that's a sort of taboo film to talk about with something, but I think that's an interesting film where, I don't know, have you seen it? You have seen it.
I've seen it.
Yeah. And I'm using that as my point of reference, but with other things. But that potential of a system allowing it to grow and develop, and then it forms its own opinion and it forms its own entity, and it decides this is actually what I believe now is moral or not. So is that's also, I guess, some of the challenges. Yeah.
I mean, so the Transcendence is a nice example, because actually there's a book that was published last year by Stuart Russell called Human Compatible. And he uses that book as a couple of sort of examples from that book as a way to help the readers sort of understand his perspective on superintelligence and how the development of artificial general intelligence would lead to potential misalignments, if you will, between the intentions of the creator, right, and the so-called intentions of the created. And so from my perspective, I think I'm critical of that point of view, because ultimately what is being done there is a kind of projection, right? So there's agency creep, in the sense that you and I we have a beating heart and we feel agency and life in the world. And so we'll tend to see animated things, even mechanically animated things, from that projective perspective. And that's not something that's new to super intelligent AI. That's the very origins of animism and ancient totemism and various other religious kind of self-conception. And so one of the sort of cautionary moments, I think, of our contemporary life is that we're becoming, in a sense, better and better at creating machinery that seems like it has the type of lifeblood agency that we have, and that in a sense it causes some misconceptions about what's actually going on, and it's a dangerous thing, because we will tend to see ourselves as, the fancy word is like the demiurges, creators. Like the whole idea of us being able to kind of create the next intelligent agent, right, is, I think it arises from a very kind of crypto religious point of view. And I have no doubt that we can create dangerous instruments, given the fact that we are able now to use statistical and probabilistic programs like reinforcement learning and reverse reinforcement learning to have systems that are able to sort of operate independently in open environments. I mean, we have capacity to create so-called autonomous systems, right? But it doesn't mean that those systems are endowed with the kind of agency that we would understand in our kind of from our biological starting point. And so it's a real, we face a real hazard that we start to sort of get out of our lanes, if you will, right? When we think or talk about what the potential is for artificial intelligence. I mean, this is one of the reasons why the actual name itself is an issue, because intelligence is something that is not we would say it is not perspicuous language if we think about what data science or artificial intelligence science can actually do, right? It's not something that has a constrained and falsifiable way of being verified or thought about in the world. And so we'll tend to become very kind of intellectually licentious. We tend to become sloppy when we start to talk about, even in transcendence, when we start to talk about the kind of machines coming to have these kind of very human-like or even beyond like superhuman-like capacities.
Can I ask you, when you talk about the autonomous systems that have been created, where is that? Do you have any examples of everyday interactions that we could have with an autonomous system that's been created by AI?
Yeah, I mean, so the things that are being developed, and we can think of unmanned aerial vehicles, and we can think of autonomous cars, right? Autonomous vehicles. I mean, there's just a ton of possibilities in the rising Internet of everything, in the rising Internet of things, where we would have systems that are acting with open environments, and us being part of those open environments, where they're not, in a sense, pre-programmed to have a kind of a direct and knowable response in advance of the operation, right? And so one of the things that makes a system fully autonomous is that it won't have the type of advanced design time, pre-programmed to environmental situation that we can specify and regulate and control in familiar ways. And so you have this thinking just about autonomous vehicles like cars, right?
Yeah.
You have these situations now where if you have an autonomous vehicle on an open highway, it's a much more manageable situation, because the various conditions are much more controllable, and the kind of decisions made by the system seem to be more assured.
It's not complex. Yeah.
It's not complex. But now put that autonomous vehicle in an urban environment where you've got children running into the street, and you've got novel and culturally specific activities, practices, reactions all around. And how then, if it is a truly autonomous system, which is what the aim is ultimately for these things, how then does that very complex system operate in that very complex environment in ways that are safe and that we could justify as a so say we were manufacturing one of these things, like how can we justify that the autonomous vehicle made a left, right, and swerved to avoid this person or object and hit this person or object instead, right? I mean, so there's a whole kind of another series of problems that arise in that type of situation.
What do you think is the future of AI?
I think it's a difficult question. We've talked a lot in terms of we in those who are thinking about AI in its history, talked a lot about how there are these sort of cycles of AI winters and springs, and the winters are always caused by the kind of building of expectations that don't quite fit with the level of our technological efficacy. And I think that we're definitely at a point where there is, in a sense, a new tech bubble where there's a lot of inflated expectations about what certain systems can or can't do. And this goes to the kind of world of anthropomorphic projection and superintelligent INSEE and all of the resources that are being dedicated to thinking about things like value alignment, et cetera. I think that world is a world that it has a lot of distraction in it from what it actually means now to be able to use these technologies responsibly to aid our progress in achieving public good, to sustainable development goals. I think rather than focusing on that kind of area of artificial general intelligence, we should be really thinking about more narrow applications that will support. I mean, there are so many potential benefits of using these types of algorithmic systems to address ecological and environmental issues, to think about better ways of having equitable agriculture in the world, other supportive ways of using AI and machine learning to address real social problems that we face. And so I think the sort of good future, the good possible future, is to increasingly think about machine learning and AI as a kind of public utility, a kind of source that needs to be drawn upon, as I said before, in a democratic way to address real social problems. One of the things that we often don't talk about is that technology isn't geopolitically dealt, right? So like the machine learning technology isn't British or European or Chinese. No, machine learning technology is an affordance of our species. And until we step over that hurdle of thinking in a very narrow way about the interests of our country or the interests of our company, we won't fully use our technology in the appropriately responsible and ethical ways. And so thinking about where AI is going in the future of AI, the hope is that as we come to deeper understandings of that universal species level character of our technology, we will be able to shed some of the sort of prejudices, some of the biases, nationalistic biases, other biases that cause us to misappropriate our capacities in technology.
Thank you for that. And just as a last point, if from everything we've spoken about today, we've spoken about so much, and it's been so important, but could you just, as we close, give us your take home? What would you say are the key take home messages from today's conversation?
Well, I think first that I love talking to you. I mean, it's been really nice to sort of explore
Thank
this.
you.
It's not a lot of times we just have our kind of nose in the laptop and the books, and we're trying to like write what we need to write and do the deliverables in our research, right? But it's nice to have the wider ranging conversations, and I think that for me, these sorts of conversations are so important in general, because we need to think with the wider angled lens in order to really be responsible about how we use AI and machine learning systems. And so that's, I think, the fact that we're able to range beyond just the specifics and talk about the bigger picture issues is one key takeaway. I think also, if I could just flag the importance of public engagement, the commitment that you're making in doing this podcast to me, and why I think it's important for us to be here, which is just, we do need to improve our sort of public discourse on AI technology, because I do think there are a lot of misconceptions about what's actually going on with artificial intelligence. And I'll just say just one last brief comment. In the ethics in machine learning and children's social care research that we did. And also in the Institute and the Information Commissioner's Office wrote the sort of Project Explainability Guidance, which was published I think in May. And in both of those projects, we basically had a public engagement where we went out and in the children's social care research, we talked to families with and had a whole day where we went through what is machine learning and went step by step through what's actually going on in technologies. And in the SEO Turing project, we had a few days of citizens juries where we actually had a day or half a day of education on certain things, and then more kind of enrichment, and then collaboration, discussion amongst representative set of citizens. And in both of those instances, one of the takeaways was common, which is that there was a transformative effect on citizens where they did feel that once they understood what's actually going on in the statistics or in the modeling, it shed that kind of mystery of what AI is. They felt empowered. They felt like they could make better sort of judgments and decisions about how they would have their values steer the course of those whatever technologies. And so I would say my second takeaway is just that the public discourse dimension of this is super important, and it's something that it just needs to continue on and build off of itself.
You've been listening to the Monday Science Podcast, a weekly show bringing you the latest research and news in science, technology, medicine, and health. We hope you've gotten some useful and thought-provoking info from the show, and we hope you had fun along the way. We know we did. We'll be back soon, but in the meantime, hook up with us on our website at www.mondaysciencepodcast.com. Shoot us an email at info@mondaysciencepodcast.com. Find us on Instagram, LinkedIn, and YouTube at Monday Science, and access episode summaries at mondayscience.medium.com. See you next week on the Monday Science Podcast.